All right, this is Mr. Hayden. This is week 13, Earth Science. All right, so a couple things. One is that the stuff that we're going to go over today is so vast and so theoretical that in some of the things, good, come on in, now relax, yeah, chill, just go, yeah. All right, so it's very theoretical, okay? And so the problem I have is that when we talk about everybody talk about atoms and molecules and all that other stuff, and you're like, oh, this is boring. Well, the problem is that if you're not like super jazzed about like space, try to stay away, okay? Because some people don't like space. Some people don't trip out about certain things. Like I do. Some people don't care. Whatever it is, just try to bring it as best as you can. Right? It's hard. All right, next. So a few things that we need to go over before we start. Is one is the science notebook. Now, if you started today, or if you started a week ago, or 3 months ago, or at the end of the semester, you should start the science notebook. You should have notes that have progressed through there. You should have your graph in there. There are things that I told you very specifically need to be in the science notebook. And so just remember, you have about 7 weeks left of school. So if you don't have that done, you need to go back and get it done. It's 100 and something points of your grade. And I don't want to be the guy that if you have like, say you're like, yeah, I fully found the D, yeah! You see your science notebook. Oh, about that. Because I'll tell you. I mean, it is what it is. I don't try to like, well, I really like her. I really like her. It's not going to be like that. It's whatever the numbers come out to be. Okay, I must not go, oh, your numbers is not your number. But 8 numbers say it comes to be at 55. So you don't. Sorry. There's nothing I can do for that. You should try harder. Next time, try harder. You'll even know 5% more than have never taken this class again. So we'll make sure that we have 7 weeks left. You can go back and you can do it. If you have a question in your science notebook, I'm probably the guy you should ask. I've looked at a few of them already, and a few of them were awesome. And then a few of them, they looked at me and went, we have 7 weeks to do the notebook, right? So, yes. And so just make sure it is proper. So one thing is do not plagiarize. No one in this class. But some people in other of this class, but other people, they decided that they just copy and paste. And by the way, don't also reference your student guide. Like, don't reference something for the student guide and like you're trying to reference it. You can't reference the student guide, okay?
Wait, no. Notebook?
Yeah. No. I'm sorry, on a test. Oh. On the notebook, I really take care of it. So plagiarism is not cool. Also, you want to make sure that if you are, like, say, turning in, like, samples of work and stuff like that, you're not just copying and pasting from the slides. Okay? Like, it's your own notes that you're supposed to be taking. Okay? Just make sure, because if I get a science notebook that's just copy and pasted everything, I'm not accepting it. That's plagiarism. It needs to be your writing. Do me a favor too. When we get to the final, believe it or not, some people actually finish the course with that. So good for them. Do me a favor. Don't plagiarize on the final. It's worth like 160 points or something like that, and you will get 0 on if you do. Have that happen. People fail the class because they decided, and if they would not have done that, we got a B in the class. It was bad. I felt bad, but it's not good. So just make sure that you do that, okay? Or don't plagiarize. Make sure you do your science notebook. Is there anything else you guys want to go over? Well, how awesome my hair looks. Chris Ross? No? Chris Ross, no? Don't be jealous of the hair. Look at that. Don't be jealous of the hair. No, my little son did. No, I went to a barber, professional barber. Cost me $10.
No, you can all the time.
Oh, that was my class. All right, next. Okay, so the essential question for this week, and by the way, there's like a couple words in there that might trip people up because it just depends on what book you're reading or what curriculum you're looking at. They call them different things. So it says, what are the differences between the terrestrial and the Ethiopian planets, and why do you think such differences between the two? Why do you think there's such a difference between the two? Why do they? Today we'll talk about how like the formation of the solar system. We'll talk about that and a bunch of other things. No, believe it or not, There's two different words for terrestrial. Okay, terrestrial is actually everything on this planet, but it also just means the rock on this planet. And so terrestrial planets are more like the smaller rock planets that are not the gaseous ones. Those are the Mars, Venus, Mercury, Earth. Those are all terrestrial. Then there's the Hadean or the gas planets. Those could be your Pluto, your what's the big one? Jupiter, Saturn, Uranus, Neptune. And then Pluto's a planet, okay? So when I rolled when I was a kid, they just changed it on me. You can't do that. Come on. They did, I know. They did really. I tried.
I told him so but and that's what I said. Never forget.
Never forget it. That's hilarious. All right, so just make sure you know those differences. Cool, good for us. Cool. All right, I'm going to go ahead and copy and paste into the URL for the people on the internet to watch the video. I'm going to copy and paste because I'm a professional. Professionals can do that because I know how to reference to it. But I'm going to go and copy and paste for them, but I'm going to give them time to go out and watch it. And then for us, I'm going to do the exact same thing. So give me a second here while I bring it up. Give me a few seconds while I bring up the stuff. For science. Relax. Relax. It's okay. We'll be done soon. Now you guys are getting a little antsy. Okay, so here, one second. All right. Okay, go ahead and watch that. We're going to do the exact same thing. I'm going to set the timer, and I think it's about, let's do 6 minutes. I think it's about 6 minutes or so. We'll come back, and we'll talk about what we saw. It's really need to show up in person. We get really kind of fun conversations on the side. All right, you can watch the other video. We'll put in there later. If you remind me, so I'll probably forget. It just shows specifically how like the sun forms. But what you guys saw is basically the formation of the Earth, and the formation of the Earth is a rocky planet, and then also the formation of the sun, and then how it kind of blew out all of the dust and everything out of the way. That's why everything is pretty. So our Earth is made up of dust. Rocks and minerals and all this stuff. And when we were talking about, we'll get to later, but in theory, when you start looking like some people were tripping out on some of the information I've given them. So we'll get to that. This right here is the solar system. Everyone really stuck on that? This is the solar system stuff in 4th grade. Probably did little models of it, painted and stuff, spun it, or did like pictures or something. Yeah, no?
I've done one.
Yeah. Everyone's done it? Okay, so this is what people trip out about. Is that you guys have 4, or I don't know if you guys have high definition TV, flat screen, TV, flat screen TV, TV that you watch, television, YouTube. I don't know. I look at some people and they're like, LCD, plasma, anyone else? LCD, or super high definition. You have at least 4K now. I would work. 4K TV, everything's high definition. Your phone's high definition, all this stuff. That's like 2003 high definition space picture. Those 3.
Do you think that was the one?
Yeah.
It's like an iPhone.
Yeah, this is like
Definitely.
They put the they have to put it inside of the
2003 civil phone section. Yeah. All right. So what this is what we're trying to show you guys is that this is what they look like. These are a certain filter that allows them to see like rocks and things like that. So all those little balls stuff out there, those are all either big rocks or planets, things like that. Pluto is not the only planetoid, whatever they call it, or mini planet, or whatever they miniature planet, or dwarf planet, whatever they're trying to call it now, out there. There's the Sedna, there's the Quaoar, there's all these other rocks that do rotate around here. There's other ones out there. We just can't see them. They're so far away. I mean, look what they gotta look at. They gotta look at that and go, ooh, look at it, planet. They're like, no, let me clean the lens. Oh, no, that's a planet. No. I cactus up on it. It's just a little dirty. I mean, look what they gotta look at. It's crazy. This is what they use. So I just find it interesting. All right, so this is our solar system. Now remember a couple things. Our solar system is about, I don't know, let's say 10 billion miles wide. Don't know. You're the person who made it. I borrowed it. Professionally borrowed it. All right, but basically, look at that. It's 10 billion miles across. Our solar system. Our solar system is just a little dot inside of the Milky Way galaxy, which is just a little dot inside of space. Which is great. And you're just a little dot. You're on Earth. You can be. Keep it up. You'll just do it. All right. So look at this. Right here, this is our Milky Way galaxy. It's a cloud arm of the galaxy. It's relatively flat planes now because of the way circular motion works. Like you ride a bike, wheels keep you up, that thing. When it starts spinning, they all kind of like pull down into a flat line. Some galaxies have two rotations. One will rotate this way and one will rotate around this way. It's a really weird one. It's a 100,000 light years across. That means going 300,000 kilometers per second fast. It'll still take you 100,000 years to go across it. That's big. It's 400. I mean, relatively speaking, this is a small galaxy compared to the space. So, I mean, come on. So the nucleus is in the middle. This is, oh, really, no, this one doesn't show us. Oh, our sun's location is on that one little dinky arm on the bottom left. That's like where our solar system is at. Just a little, it's right there, little dinky thing on the left. Because we're not the center of the universe, even though we all think we are. We're not. I am the center of the universe. Everything rotates around me. All right, now this is what we start tripping out about. This is what, this is a picture of about more than a million stars. Yeah, it looks like static TV, it really does. But no, think about it. Every single one of those little white dots is a star. Just like our sun. Not planets, just the stars that could have planets around them. Think about that for a second. Anyone else not tripping out here?
I'm tripping out.
Yeah.
Is that all in our solar system?
No.
Or is it 7 different solar systems?
No, this is just looking out in that little, like, this one direction.
Is this on the left arm of the Milky Way?
I don't know what arm it is. We'll say it's on the right arm of the law.
Like what?
The law. So look at this. Every single one of these little dots, like this little dinky dot you can really see here, barely see it. It looks like just pixels. That's a star, just like our sun somewhere. But it has planets probably around it. Could have life. Who knows? We haven't got there yet. We're not smart enough. We're not smart enough to get there yet. No, we're not. It's cool. We're just not smart enough to get there yet. Eventually we will be. But we just can't do it. We can't go from here to there. Nobody knows. We don't know how to do that. Saw a movie about it. I saw a movie I saw this movie where like the students all showed up to school and they wanted to be there and they all learned and got A's. Both of them were fiction probably, but they did. It was really good. The Hope Society.
Oh, that'd be a really good movie.
It's a really good movie. All right, so just look at this. Now, this is from an old, if you ever watched the movie Contact with Jodie Foster way back, it's from like the 90s. There was like a saying, like she says a whole bunch, like there's like these sayings, like it's like inspirational. She says, there's millions and millions and millions of galaxies out there. Each one of those galaxies has millions and millions of stars, or planets, planets. Each one of those has millions and millions of planets around them. If one out of a million of those happen to be within the right distance away from the sun, and one out of a million of those happen to have the right elements to create life, there should be millions of planets with life. Based on odds, I mean, I don't know. If you look at odds, it's like there has to be. We can't be the only ones. Maybe we are. I don't know. But if you just look at it, I mean, you're saying that nope, we're the only ones. No, we're it. That's us. Look at us. We're it.
One of a kind.
One of a kind. But if you don't think about that, there it is. And again, this is all based on the idea of evolution, Big Bang Theory, all this stuff. Creationism, obviously a completely different concept. But whatever you believe personally, it falls within it probably. To an extent, it should fall within the idea that we're here now. And we should probably at least have an idea of what we think on, but more of what we're doing forward. We get a good grade. Most important thing in life. All right, this is another picture. It actually says that it's an edge view of the spiral galaxy. Our galaxy, I'm going to take a guess this is not a real photo, because how did they get a picture of the outside of our galaxy looking in? Just saying. Just saying. I don't think it's just probably not a real picture. Here's another little picture. This is a picture of the Milky Way galaxy. All those little dots are stars, just like our sun. With planets all the way around it. It's crazy. Yeah. I mean, it's weird. People were tripping on earlier because I brought up a concept to them that when you look up in the sky and you see a star twinkle, twinkle, little star. When you look up there, right? Hey. Remember, the star up there is probably not even there anymore by the time it gets shut off.
Well, because it's like astronauts and it's going to take like 8 minutes.
It might take longer than that. Sometimes it'll take 100,000 years, sometimes a million years. A little longer.
Oh no, that's from us to the moon or us to the sun.
Probably our sun.
Yeah.
But it's really cool.
It's 8 minutes.
So check this out. Here's a star just chilling out in space. By the way, I'm now on I'm on the board real quick, and I'll try to get back to you guys on the internet. But there's basically a wave shoots off of here, right? That's what light is. It's a wavelength. It hits you in the eye. That's how you see it. That's how our eyes work. We see light. If we don't have light, we don't see. Well, what happens is this time could take 1 million years or so, or whatever it is. Well, what if this beam right here gets shot out? 1 million years it hits here. But after that, it explodes. It means the light goes off. But we would never know that because this wave is still pushing through space and hitting you in the eye. So sometimes when you look at the sky and see stars, some of them may not make you be there at this time because they're gone. But the wavelengths are still moving on. Because right now, if anyone knows out there, and they look up in the sky and they see a little dot, they probably see our sun. No. There's really nothing there. Maybe they go there and be like, oh, look, there's the moon, there's a wave! Or, okay, let's go home. Let's not have anything like Apollo 13 happen, please. I'm looking at it, I said yes.
How does it work with telescopes?
Huh?
How does it work with telescopes?
Takes in a bunch of light and focuses it to be able to see long distances.
No, but like I'm talking about like the star, the wavelengths. Would it hit it faster? Or?
No, it has nothing to do with that. It's the clarity of it. It's basically ultra high definition. Like really expensive, really perfect lenses. They're even now more perfect than other stuff, and they basically help catch that light. They're trying to catch the light. Take a selfie with the selfie on the moon. Yeah, you see all your pores. And you think, oh my gosh, I'm going to say it on my podcast. Really creepy. All right, here's another picture. We'll go a little faster now. Okay, so Big Bang Theory, real quick. Idea that a bunch of stuff goes into the center of the universe. Present stuff like a basketball explodes. Everything is created from there. There's the things in the test called redshift theory. You should probably know. Write it down. Redshift theory. It's the idea that when you look at something and you go through a special lens of light, anything that's moving close to you is in blue light. Anything moving away from you is in red light. And everything in space has red light. Which means everything is moving away from everything. And the only thing that we know on this planet that moves away from the center point is an explosion. Explosion that moves in every direction, all the way from each other in a vector. Yes.
Oh, sorry.
Learn that stuff.
Sorry.
All right, so Big Bang Theory, good concept. There's another picture of our solar system. Again, there's also in the center, there's an asteroid belt here. There's also an asteroid belt kind of goes around here. It's more of a cloud. What? Oh, we're a belt. Here she went there. Here's the moon. You should already know this stuff because we already went over the moon Earth relationships on this thing. By the way, some of your answers for your tests were really awesome. Also, this right here, here's the moon. What do you notice about the moon?
Pores.
Yeah, we've got a bunch of black heads and pores and stuff. Well, basically, those are all areas where it got hit by an asteroid. Or meteor. And there's no atmosphere on the moon, so there's nothing to protect the Earth. It is. And the Earth actually looked like that too when it was being formed. Now, there's a difference. We have an atmosphere. We have nitrogen and oxygen and O3 and all this other stuff out there. So when the asteroid hits the Earth, it basically runs into a whole bunch of stuff and goes, ow! And starts ripping apart and breaking up shooting stars. So that is the breakdown of a meteor, asteroid coming into the Earth. That's what that is. But remember, we look just like this at one point, because every single day, guys, we get hit by meteors every day. Every single day. Here's like a little graph of what it looks like. So every hour we get hit by somewhere on this Earth, we get hit by a meteor the size of a meteor, about this big. Okay. And then every day, every hour or so, somewhere. That's why you look kind of every hour or so, if you're in the right place, you should be able to see something. Yeah, it's a meteor entering their atmosphere. Not really sharp shooting at us now. Just throwing it out there. Every year they go a little bigger. Pay attention. Every century we have a larger one, maybe 10 meters. Every millennium we have a larger. As you go down the y-axis, every 100 millions of years we get a big one. One thing I find interesting is look at the every 100 million years. If you go all the way across, it's about 10 kilometers wide. The rock, let's say it's about 10, whatever, let's do 10 miles, make it easier for the U.S. 10 miles wide or 7 or whatever it is. That's it. It's big. It's going to end life on Earth, pretty much. So when it hits the ground, guess how big the meteor is? The meteor is the size of us to LA. 10 mile wide, size of Elsinore, rock. Hits from here, probably past LA is gone. Instantaneously. Crazy. And then other bad stuff happens around it. Don't get into that. So that I just find it interesting. And then this does happen. Okay, and every once in Earth's history there's even larger ones that can completely change, like knock us onto a tilt. Things like that, or knock us off par. Those aren't going to happen hopefully anytime soon. I'll check my calendar. On a Google account, there's nothing on Google, right? Did I check Facebook today? Is there anything happening like that? Just making sure. I was checking Facebook just to make sure that the world is in. Nope, we're in. We're good. I had to check my Instagram too. I check all of them to make sure. Didn't check Twitter. Sorry. All right, just so you know, this is basically the end of Earth is at high noon. Not today. Sorry, guys. This is just a theory. Earth started right after 12 o'clock. We're really not even halfway through really the Earth's life. Miracle will be here long after us. Humans might not even be here in general when it ends. Eventually, the sun will give out its energy. It will expand. It will engulf many of the planets, and then it will collapse on itself. It will not create a black hole, but it will become. So no one will be here. So it's cool, right? Okay.
Are we going to be like on the 6.7 if I don't
No, it won't be alive.
Well,
And everyone in this room will actually go.
no, I'm talking about humans.
Maybe. I don't know. I have my own theories. People have other theories. I think an asteroid big enough will probably hit us by the time that happens. But I do think now that we're smart enough to move it out of the way. Because really, it's not like you guys did Armageddon, right?
No.
Yeah, like you can, we're like explode and oh, we're going to blow it up. We're going to blow it up. Yeah. We really don't need to do that. We really just need to slow it down a little bit. Then the Earth will just pass out of the way of it. It'll just fly right back. Literally, just slow down or speed it up. One of the two will happen.
How will we do that?
Well, if you think that, like, say you're spinning in a circle, and you're spinning and I don't even hit you. If you speed up a little bit, you'll miss me. If you slow down, you'll miss me. Right? It's that exact moment of time. Those are Or you got to slow down. There's ways to do it. There's so many people out there now coming up with theories on how to do that right now. Using solar wind, and using this, and putting something like, basically putting a huge magnifying glass on it to heat it up and create more energy, and therefore it'll speed up or whatever it's going to do. A lot of theories. I think we can survive it now. I do think humans will be, if they're alive during that time, will be smart enough to survive it. I do think that for sure. But I also think that humans, by the time we smart enough to work things out, we'll go find another planet somewhere where we'll make
Border around Earth, and that's protected with the fact
We do.
that
We do. Called air. No, these theories. That's what that is. That's exactly what air does to us. It protects us just like it does.
how do the computer students start get through that?
It doesn't get through it all the way. It does sometimes, but not all the time. No. It's like you jumping into water. When you jump into the water, you just continually go on forever until you hit the bottom of the ocean. No, you stop. It's like the meter hitting our air. It's the exact same thing. It changes from a no medium of nothing but vacuum to a medium of air. Same thing. It slows down and breaks apart. Just like if you jump off of a bridge into water, you don't live. Because your body and everything literally breaks apart. Just like the meter.
I mean, I guess it depends on how things go.
Nope, doesn't.
I jumped off the bridge.
Doesn't go against anything what I'm saying, therefore it's wrong. There's just so you know, here's some of the orbits. You can see the weird one is Pluto. Probably led to the whole like non-Pluto planet thing. All right, just so you know, this is what the inner planets look like. So obviously, you know what Earth looks like. You know what it looks like. Still outside. We don't actually have photos of Venus because basically the clouds like sulfuric acid, and it's a huge greenhouse effect. It's super hot. It's pretty much melt anything we sent there. So bad. We don't know that looks like. We theorize that's what it looks like. We do know what Mars looks like because we sent the rover there. Really, that was like $10 billion. It's really nice. $10 billion. You guys ever see how they actually did it? Watch it, like a quick documentary on YouTube of how they did it. They literally like blew up like all these balloons around it and like just let it like hit the ground and just like bounce all over the place until they finally stopped, and then they think like let the air out of them and flip it over, and it's really kind of funny. It's like that's the best way. That was the best way you thought it was. Let a ball hit the earth or hit the ground at like however many miles an hour and bounce around until it stops. That was the best option. You can already blast that because that's it. Rocks, typically no rings, very few planets, very few moons. We happen to have one, good for us. No rings. No, it's not like the Lakers who would have like 12 championship rings. No, not like that. Yeah, 12 rings, yeah, I tell you. No, we got another team, and then I know it. So you have the places. Alright, so this is the Homeoneer of the gas planets. These are typically large, they're gaseous, they have rings, they have many moons. They're further away from the sun, so therefore they can have their own gravity to hold on to these larger, these multiple moons, and all these the dust and clouds and whatnot. They're like a little other solar system. Which one's the one that was 6 months ago? Someone asked that question in last class, and you did that and just mess with me. Told you to Google it. One of them's rotate. You know, like Saturn's like kind of tilted. Well, one of them kind of rotates on its side. It's like it almost looks like it's rolling through space, and it has like a rotation. I don't know which one it is. If I was to guess, I would say it's actually the dark one, but then the one next to the left one is the one straight up. I would guess that one is Granny. I'd say Granny. Yeah, oh. I would say that's what it says.
The bottom
left.
Yeah, that's what I was thinking.
All right. Oh, this right here is for your own awesome fact sheet, if you like. It just shows how big they are, size, rotation, things like that. If you really even care about it. The ones closer to the sun rotate faster typically because they're closer and they spin around it faster. The ones around the outside spin slower. That's why, like figure skaters. Anyone skate here? Figure skaters. Figure skater. Maybe. You know you're spinning, and you take your arms and you bring them in, and you spin faster. That's the idea that you bring it closer to the center of the nucleus, you spin faster, plants spin faster, same stuff. Sorry, I thought I had to let people know that you do that. All right, here's a terrestrial. Here's some more information again. This might help you on answering the essential question for the people on the internet. So you definitely may want to pause there later and watch that. Here's the various belts and clouds that rotate around the outer part of our solar system. Again, they're not hugely needed to know, but if you're getting into this, you can learn it if you'd like to. That's really about it, guys. Nebula theory just kind of gives you a systematic breakdown of actually how the various planets form, as well as you can even see how the sun actually itself turns into a protostar and then also breaks down. That's important for the test. It's going to ask, I think, on the test, if I remember correctly, to list basically like the life of a sun. All starts with birth. Then they grow up, and they move away, and then we can go travel and be happy. I mean, sorry. There's a pictorial version of that. And I'm just clicking through this because this is all extra stuff. Just leave it on there long enough so you guys can pay attention if you'd like to. All right, so I'm going to go through. Is there any questions at all? The question is on the very front page. If you need to go back, you can rewatch it. How do you know how the Milky Way galaxy looks if we are in it? Exactly. Good point. I think they're theoretically guessing what it looks like because we've sent probes out into space, and I think one of them just reached the outer part of our solar system. It's been like 40 years. It's been like 40 years, and it finally left our solar system. It's like really far away. But yeah, I think they're just guessing on what it looks like because they know what it looks like from the inside. Like if they're inside looking out, they can still see the clouds, dust. They can see the rotations. They can look at the planets and kind of put them into models and actually show that they're moving. So they can do it mathematically what they believe it is based on physics, but they're just guessing. Yes, you can make up work. No. Okay. All right. Any questions? I'm going to go ahead and throw that second video up here for you guys, in case you guys want to go and watch it. Give me a second. Went back in. Paste. Okay. There you go. Just in case you guys want it, there it is. And I'm going to go and stop the recording. And you guys have a good rest of the day.